Hey guys, so for day 2, you're going to need a piece of scratch paper for one of the examples just because there won't be enough room. And I want to make sure I'm very thorough on that example, so just so that you can get that ready. So if you need to press pause, do that now so you can get that ready. All right, so we are on 3.5 notes, day 2. So this is a continuation of the first lesson, okay, day 1. So we know that sine squared plus cosine squared equals 1. That was an identity we learned back in Math 3. Second semester. The derivative of 1, or the derivative of any constant, is going to equal 0. So these are two things that we know. We're going to show that the derivative of sine squared x plus cosine squared of x equals 0. All right, so let's start with this. The ddx of sine squared x plus cosine squared x. We're going to show that it's going to equal 0. Okay. Well, let's break apart the sine squared and the cosine squared. That's going to be our first step. Because then we'll be able to do product rule once we do that. So sine squared is basically the same as saying sine of x times sine of x. Okay. Plus cosine squared would just be cosine of x times cosine of x. So we basically get to do the product rule now because we have a quantity times a quantity, but we get to do the product rule twice because of that plus sign. There's two things that are being added here. So we'll use the product rule on this set, and then we'll use the product rule on this set. Okay, so let's try it out. So when we're using product rule, let's just pretend that this isn't a part of it yet. So we have the first times the derivative of the second. Well, the derivative of sine is cosine, plus the derivative of the first is cosine times the second, which is sine. So we did the first half. Now for the second half, we pretend that this first half doesn't exist. So plus the derivative of cosine, or sorry, we usually keep the first, but it doesn't really matter. The derivative of cosine is a negative sine, plus the derivative of the first is a negative sine times cosine. Okay. So when I clean this up, I have sine x cosine x plus basically another sine x cosine x, so I have two of them. Two sine x cosine x's. And I basically have a negative sine x cosine x and another negative sine x cosine x. So I have two of those also. Hey, 2 sine x cosine x minus 2 sine x cosine x, that equals 0. We just showed that it's going to equal 0. It does. Woohoo! It's kind of cool how that works out. That's pretty much the only thing that I like about proofs is when they work out and they're really not super crazy like the geometric ones. The geometry ones, those ones, I always hated those. You get better at them over time, especially when you start understanding them a lot better. But these ones, the trig ones, have always been my favorite, even when I was your age. All right, example 2. Write the equation of the tangent line to f of theta, which equals tangent of theta, at the point pi over 4, comma 1. Okay, so since we're writing the equation of the tangent line, that means we need to find the slope, which means we need to take a derivative. So we're going to take a derivative of f of theta. So f prime of theta is going to equal, well, the derivative of tangent of theta from the last lesson is secant squared theta. And now let's plug in the theta. We know that we're doing it at the point pi over 4, 1. So pi over 4 is our x value, so let's plug it in. So f prime of pi over 4 equals secant squared of pi over 4. And now we got to take it to the unit circle. Pi over 4s are one of the easiest things to remember on the unit circle. Remember, it's a 45-degree angle there because it cuts that quadrant in half pretty much, and the coordinates were square root of 2 over 2, square root of 2 over 2. The easiest x and y coordinates to remember, like ever, besides the 1, 0, 0, 1, negative 1, 0, and all that. Those are easy too. I call them the four corners. But the pi over 4s are also easy because they're the same x and y value. All that's different around the unit circle are the signs, depending on what quadrant you're in, where the x is positive, y's are negative, and all that. Okay, so secant is the reciprocal of cosine. Cosine is the x value. So I'm going to use the x value of this, but I need the secant version, which means I've got to flip it. I've got to use its reciprocal. So, and since this is squared, this would be the square root of, got to flip it, 2 over the square root of 2 quantity squared, which now the math is pretty easy to do because we have to distribute that power of 2 to the top and the bottom. 2 squared is 4. And anytime you square a square root, the stuff inside gets to come out. And 4 divided by 2 is 2. So the slope is a 2. Because remember what we're trying to find. We're going to write the equation of the tangent line. So we need t of x. And this time they were nice. They gave us the x and the y value, so we don't have to go search for the y value. So we can just go straight to the answer. T of x equals 2 times x minus the x value is pi over 4. And the y value is positive 1. That's it. So I know that because of the trig, it makes it look really scary. But guys, it's really not. You just have to give it a chance. Give it a shot, okay? Just try really hard not to give up on me here. Just keep plugging away. You guys are doing great. Just keep it up. All right, example 3. A body is moving in simple harmonic motion with the position of s equals 2 plus sine t. And this is in meters per t seconds, so meters per second. And it says, letter A, find the velocity, the speed, and acceleration at time t. Okay, I like the flow of this. I think you guys are going to like it. I'm going to color code it, so I'm going to use 3 different colors. I'm going to start with blue for velocity. When we're finding velocity, that means we're looking for v of t, which is the same as taking the derivative of the position function. And the derivative of this, well, the derivative of 2 is 0 because it's constant. And the derivative of sine of t would be cosine of t. So the velocity function is cosine t. Next color I'm going to use is red. I'll use speed in red. Remember, speed is just the absolute value of the velocity. So it's just the absolute value of the cosine of t. So if I plug in a number for t and it ends up making the answer a negative, well, I'm taking the absolute value of that, so it will always be a positive answer. Because speed is never negative. You don't go negative 55 miles per hour. You just don't. All right. Excuse me. My mouth is dry. Acceleration. Now this is where we're finding a of t. This is how we usually write it. And this is also the same as taking the derivative of the velocity function, which is the second derivative of the position function. Okay, so the derivative of cosine of t, well, derivative of cosine is negative sine, so it'll be negative sine t. Okay, and we found all 3. They kind of flow. They go in order. Like that's the order that you have to go when you're finding velocity, speed, and acceleration. All right, letter B. Find the body's velocity, speed, and acceleration at a time of t equals pi over 4. So now we have something to plug in. So let's start with the velocity. So notice I'm keeping my color coding true. Velocity would be, we need to find the v of pi over 4. So we're finding the cosine of pi over 4. Well, cosine of pi over 4, if I refer back to my unit circle here, there's pi over 4. Cosine is the x value, and that is square root of 2 over 2. So the velocity is square root of 2 over 2. And what were the units? Meters per t seconds, so meters per second. Easy peasy lemon squeezy. Speed. I am speed. I don't know why I was thinking lightning McQueen all of a sudden. I'm such a dork sometimes, guys. All right, so the absolute value of the velocity will be absolute value of square root of 2 over 2, which is just square root of 2 over 2 meters per second. It was already positive, so taking its absolute value was no big deal. All right, acceleration. How fast are we accelerating? Okay, well, we have to plug in the pi over 4 for the t there. So that would be negative sine of pi over 4. Well, sine is the y value. We know the y value is square root of 2 over 2, but there's a negative in front of that sign, so it's a negative square root of 2 over 2. And remember, acceleration is finding the rate of change of the rate of change. So it's meters per second, which is the same as negative square root of 2 over 2 meters per second squared. So when we're finding the acceleration, the units that are in the denominator are always going to be squared, because you're finding the rate of change of the rate of change. All right, this is the part where I'm not going to have a lot of, this is not enough room at all. So we're going to go to our scratch paper for part D. This is where we have to describe the motion of the body, which was all basically what we learned in 3.4, day 1 and day 2. Okay, so let's take this to the scratch paper. So this is letter C, and I'm just going to write out, we're going to describe the motion of the body. So one of the first things that we have to look at is the velocity when the body is at rest. So velocity, v of t, remember it's cosine of t, not cost, because I was looking at my notes like, what was I trying to write? No, it's cosine of t. We want to look at when it's at rest. So maybe write yourself a note, this means at rest. Okay, and let's figure that out. So at rest, it will, cosine of an angle equals 0 at 2 angles on the unit circle. Cosine is 0 up here, because that's the point 0, 1, and down here, because that's the point 0, negative 1. So those are 2 places where the cosine would be at 0, and that's at pi over 2 and 3 pi over 2. Okay, so I know we're at rest at pi over 2 and 3 pi over 2. Okay, so remember, velocity describes motion. So velocity tells us when it's turning, when it's going in a positive direction, and when it's going in a negative direction. So we're going to look at the graph of velocity, which is the cosine graph, and that's going to help us with the position of this function. It's motion. So we're gonna look at the graph of the velocity. Remember, this is the derivative of the position function, so this graph is going to represent all the slopes. And the easiest way is to refer to the cosine wave. We know what that looks like. So where's my black pen? I want my black pen for this because I want to draw a graph. Okay, so 1 and negative 1. Let me zoom in a little bit. So on our graph, because it's cosine, we'll have pi over 2 pi, then it goes 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi. I mean, I could keep going, but I'll just stop right there, because we know this is going to keep going forever. And we know cosine starts up at 0, 1, and it goes down, down, up, up, down, down, up, up, down, down, up, up. I don't know, graphing these is really satisfying, at least to me. And this just keeps going on forever. Forever, forever. All right. I don't know why Uncle Jesse's song comes into my head from Full House. You guys know what I'm talking about? You get me? All right, so remember, this is the velocity function. Happens to be cosine, so these are all the slopes. So above the x-axis is where we're going in a positive direction. Below the x-axis is where we're going in a negative direction. So let's keep that in mind. And let's identify those positive and negative directions. Start with the positive. So in the positive direction, we are positive from 0, an x value of 0, to pi over 2. So these are all intervals, not coordinates. And then we're positive again from 3 pi over 2 to 5 pi over 2. And then we're positive again from 7 pi over 2 to 9 pi over 2. And I'm going to put dot, 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 because it's just going to keep going. Where are we in the negative position? Well, we're negative from pi over 2 to 3 pi over 2, that interval. And then 5 pi over 2 to 7 pi over 2. And then 9 pi over 2 to 11 pi over 2. And it's just going to keep doing that forever. Okay. Well, this isn't enough to say it this way. We have to write it using a proper notation. So we have to get a little geeky with our notation. Okay. So let's write ourselves a note that we need to say this using proper notation. And what I mean by that is in calculus, sometimes it gets a little tricky, but in calculus, you're like a true mathematician, and you have to state things in a very general but mathematical way. Okay. So what we need to focus on, let's focus on the negatives first. How can we write this in general that works for all? Okay, well, let's look at this. We know that we need to go from basically pi, and we need to get a pi over 2. And we also need to use an expression to get a 3 pi over 2. Well, in all the x's, it goes pi over 2, 5 pi over 2, 9 pi over 2. How can I write something that will help me get to the next one every time I plug in a number? Well, basically, let's look between 1 and 5. 1 pi to 5 pi is 4 pi. And between 5 pi and 9 pi, that's another 4 pi. So it looks like we're going in intervals of 4. So we're going to use that to our advantage. So I can say 4 times n plus 1. Because if I plugged in a 0 for n, 0 times 4 is 0, 0 plus 1 is 1. That will give me the 1 pi. But I need to put that over 2. But if I wanted to find the second interval, if I plug in a 1, 4 times 1 is 4. 4 plus 1 is 5. Oh, I'm getting a 5. And if I wanted to find the third interval, I have to plug in a 2 because I started with a 0, so 0, 1, 2. 4 times 2 is 8. 8 plus 1 is 9 pi over 2. So that works. That works for my x value. Now we need something for the y value. So it's going to have a 4n. It's following the same pattern. 3 pi to 7 pi is a difference of 4. 7 to 11 is a difference of 4. So I'm going to 4 in there. But if I plug in a 0 for n, 0 times 4 is 0, but I need this to be a 3, not a 1. So I need this to be a plus 3 pi over 2. And now let's check it. So if I plug in the 0, 0 times 4 is 0, 0 plus 3 is 3, so I'll get 3 pi over 2. If I plug in a 1, 4 times 1 is 4, 4 plus 3 is 7, I'll get a 7 pi over 2. If I plug in a 2, 4 times 2 is 8, 8 plus 3 is 11, I'll get 11 pi over 2. So this is working. Okay. For the positives, we're following the same procedures pretty much. Okay. The difference is that the only oddball point out is this first one. So to state it, we're just going to have to state it as it is, 0 to pi over 2. And then we can say and then use a pattern for all the rest, okay? And we know to get a 3 pi over 2, that would be a 4n plus 3 times pi over 2. Because if I plug in the 0, I'll get the 3 pi over 2. Plug in a 1, I'll get the 7 pi over 2. Plug in a 2, so on and so forth, okay? All right, for the y value, 5 pi to 9 pi is a difference of 4, okay? But I need to start off with a 5. So I need to use the 4n, but if I plug in a 0 for n, 0 times 4 is 0, but I need this to be a 5, so I need this to be plus 5. Okay. So this is the way that you have to write it to do it properly. It's a little sticky at first. Believe me, I know it's a little more challenging, especially because a lot of this is still new, but you're still learning to be good calculus students, so just keep trying it. As long as you guys keep trying it, you're going to get good at it. It'll be okay. Okay, but you have to give it a shot. You have to try. So just promise me that you guys will try, and you're going to be totally fine, and I'll help you get to the rest, okay? All right, so let's come up with our response, because now we're not even done yet. Now we've got to write up the response. And the more that you do a problem like this, the less you have to write out all these extra notes. This is just so that you can have a good, solid example of how to do this, okay? This doesn't mean that every time you're asked to do this, it's going to be this long. This is just because we're explaining everything. So the body, because we're talking about that body, will move in a, well, we started with negative, so let's start with negative. In a negative direction for t in the set, the word funky e, 4n plus 1 times pi over 2, comma, 4n plus 3 quantity times pi over 2. And in a positive direction for t in the set, remember we had 0 to pi over 2 because that was the oddball point, and 4n plus 3 quantity times pi over 2 times the quantity, or comma, quantity 4n plus 5 times pi over 2. Where we have to talk about what the letter n is, where n is in the symbol for the integers is that funky capital Z, but I want the positive integers only because time can only be positive. And let's write ourselves a note that this means positive integers, and then period. So then this would have been the answer. So technically on that page, I could have written that in here, but we had to know where it was coming from. So there was a lot of components that I needed to explain to you guys because you're new at it, and we need to learn how to process something like that. Okay, so that was example 3. Sorry that was so long. Sorry. But it was important. Okay, let's go back to the notes page. All right, some thinkers. Let's do some thinking. Not some stinking thinking, some good thinking. Sorry, I'm weird. Okay, so it says true or false. If y equals f of x times g of x, then the derivative is going to equal f prime of x times times g prime of x. Is that true or false? Well, if we're multiplying two quantities and I need to take the derivative of it, what would that be? You have the first times the derivative of the second plus the derivative of the first times the second. Is that this? No. So this is false. Why is it false? We need to use product rule. Need to use product rule. Exclamation. Okay, number 2. if y equals the quantity x plus 1 times quantity x plus 2 times quantity x plus 3 times quantity x plus 4, then d to the fifth y over dx to the fifth equals 0. So basically, what does this fifth mean? What nonsense is that? Is probably what you're thinking in your heads right now. Well, that means that they're asking for about a fifth derivative. We can go higher than 2? What? Yes, we can go as high as we want, guys. So if y equals all this, then the fifth derivative is going to equal 0 is basically what this statement is saying. Is this true or false? Well, let's investigate it. So just so you know, I'm not going to multiply this all the way out, okay? I do, however, know that I have an x times an x times an x times an x. So I'm going to go very bare minimum here. So let's approximate this, and let's go with y equals x to the fourth. We know that the highest degree is going to be an x to the fourth, and we know that derivatives have to do with the exponent anyway, so that's all I really need, even though that isn't exactly what it is, okay? So if I were to take a first derivative of that, it would be 4x to the third. And then if I were to take a second derivative of that, it would be 4 times 3 is 12, x squared. And if I were to take a third derivative of that, let's see, bring down the 2. 2 times 12 is 24, so I would have 24x. And if I were to do a fourth derivative, I'm using Roman numerals, of that, it would just be a 24. And if I were to do a fifth derivative of 24, well, the derivative of a constant is 0. Hey, that was my fifth derivative, and it equals 0. So this is true. How about that? And we didn't even have to multiply it out all the way. You could, and if you want to still do that to see if it still works, you totally can. It's still going to equal 0, though. Just saying. Number 3, if f prime of c and g prime of c are 0, so they're saying f prime of c equals 0 and g prime of c equals 0, and h of x equals f of x times g of x, then h prime of c is going to equal 0. Okay, let's try this out. Let's take the derivative of h and replace the x with a c, since we're trying to find h prime of c. Okay, I'm going to have to use product rule here. So the first times the derivative of the second plus the derivative of the first times the second. And let's plug in what they know, because they gave us some information. They said that f prime of c and g prime of c are both 0. Oh, these are supposed to be c's. My bad, I wrote x's. Well, f of c, I don't know what that is. But I do know that g prime of c is 0. So times 0. Plus, and I know f prime of c is 0 times g of c. Well, guys, what's 0 times anything? Wipe out. Wipe out. So this equals 0. So does h prime of c equal 0? Yup. So this is true. So far we've had false, true, true. Let's look at number 4. If f of x is an nth degree polynomial, then f to the n plus 1 derivative of x equals 0. Well, that's true. If we look at number 2, this was technically the highest degree was an x to the fourth. And when we take a fifth derivative, which is one more than the exponent of that x to the fourth, the derivative will be 0. So yeah, that's going to work for any n. This I can say is true. And to back it up, I can say C number 2. Up above is what that arrow was supposed to mean. Number 5. The second derivative represents the rate of change of the first derivative. That should sound familiar because, yeah, I've been saying that. It is so true. And the reason is that acceleration, got to spell it right though, acceleration measures rate of change of velocity. Remember, it measures the rate of change of the rate of change. Number 6, if the velocity of an object is constant, so that means it's not increasing in velocity or decreasing in velocity, it's just staying the same the whole way, then its acceleration is 0. Well, if we're not increasing the velocity or decreasing the velocity, we're not accelerating or deaccelerating. So yeah, that means that the acceleration would be 0. So this is true. Lots of trues. But let's put because it's staying at the same constant velocity, so there's no rate of change. Because there isn't a rate of change. Remember, acceleration measures the rate of change of the rate of change. But if there's no rate of change, that means it's 0. Find the derivative. So now we're out of the true and false. We're going to actually find a derivative. It says find the derivative of the function. Actually, it still is true or false. So we're asking if the double derivative exists. Let me read it all. Sorry, looking ahead. Find the derivative of the function f of x equals x times the absolute value of x if the derivative of the absolute value of x equals the absolute value of x over x. Does f double prime of 0 exist? So this is the part we need to say if it's true or false, okay? Or if it exists or not. So let's do this. And they gave us that the derivative of the absolute value of x is absolute value of x over x. They gave us this part. Okay, so let's take the derivative of f of x. Well, we have x times the absolute value of x. So I have to use the product rule. So the first times the derivative of the second, and I know the derivative of the absolute value of x equals this because they told me, plus the derivative of the first would be a 1 times the absolute value of x. Okay. What's cool about this is, anyone notice some cancellations? So f prime of x equals the absolute value of x plus 1 times the absolute value of x is just the absolute value of x. Okay, so 1 absolute value of x plus 1 absolute value of x is 2 absolute value of x. Okay, so let me rewrite this so it looks a little simpler. Okay, and now we need to see if the second derivative of 0 exists. So let's find the second derivative. We have the first derivative. So let's find f double prime. Again, I have 2 times the absolute value of x, so I have two quantities being multiplied together, so I can use product rule again. So the first times the derivative of the second, which would be absolute value of x over x, plus the derivative of 2 would be 0, because it's a constant, times the absolute value of x. Well, 0 times anything is 0. So I'm going to have f double prime of x equals 2 absolute value of x over x. But now I need to see if f double prime exists at 0. So I need to plug in a 0. So I'm going to bring this up here. Switch colors. So I'm going to have f double prime of 0. So I'm going to plug in a 0 for x. So 2 times absolute value of 0 all over 0. Uh-oh. We can't have a 0 in the denominator. That's undefined. So that means that this does not exist. So does f double prime of 0 exist? Nope, it's undefined. So I guess that wasn't true or false. We had to say if it was or not. Alrighty then. Okay, that is day 2. That is everything, you guys. All right, so your homework. So your homework is going to be, again, on page 146, numbers 26 through 30 for the day 2 lesson. So they're both relatively short. All right, have a good one.